Hello, Claude. I can see you in, but I don't see your audio. Where he teaches software engineering. In 2013, Professor Laporte was awarded an honorary doctorate for his contributions to software engineering. Dr. Laporte is also the project editor of the set of ISO IEC 29110 System and Software Engineering Lifecycle Standards and Guides developed specifically for very small entities. So for me, Claude, is a very happy moment to have you here. Thank you very much for giving us the time and the opportunity to listen to you. So please, here is the class. Everybody's here willing to listen to you. So the class is all yours. All yours. Thank you very much for being here.
Thank you, Sandra. Thank you. Good afternoon, everyone. I will be showing my face for about 30 seconds, and then in order to save on the internet bandwidth, I will cut the video of myself. And eventually, as there will be questions, we'll be going back and forth with or without video. I encourage you to ask questions as we go along. Don't wait till the end because you may forget the questions. And if you want, Sandra can translate the questions from Spanish to English. Please do not hesitate to ask questions. Okay, now I'm going to stop the video and share my screen and start the presentation.
Just one thing, Claude, excuse
Yes.
me. Perdón, chicos, me olvidé de decir justo lo que acaba de decir Claude. Las preguntas me indica él que es preferible que las hagamos conforme ustedes vean la presentación y en caso de que deseen pueden hacer las preguntas en español y yo la traduzco. Y si ustedes desean pueden hacerlas directamente en inglés. Para avisar que quieres preguntar, por favor, hace la mano electrónica. Entonces yo voy a estar pendiente y apenas alguno de ustedes alce su mano, pues yo le indicaría a Claude que hay una pregunta para que él pueda contestar. Thank you, Claude. I was just going again about the questions, so everybody knows they can ask in any time. So
Okay.
thank you.
Thank you. So you see the title is about ISO standard, but it is also about software quality assurance, and both are tied together. And in the blue box below, I say that now we are celebrating over 50 years of software engineering. And I'm going to talk about that later on. So Sandra has presented me. So briefly, I was in the military, in the military of Canada for a few years. And I was a project manager to establish a software engineering center in 1980. And I was also project manager to establish the first graduate program in software engineering in Canada back in 1990. I worked for about 7 years as a process engineer or process manager at Oerlikon Aerospace that manufactures, as you can see, a weapon system, air defense weapon system. I've also been a consultant with Bombardier Transport, where I've been lucky to give courses and consultations all over the world. And I also have been consultant for the Montreal subway for a couple of times. And as Sandra said, in year 2000, I joined ETS to teach software engineering and software quality assurance and software process improvement courses at the graduate level and software quality assurance courses at the undergraduate level. And since 2002, I've been the delegate of Canada to ISO as an expert in software engineering. So that summarizes my career. My school, ETS, has about 11,000 students. It is an engineering school, so only engineers are studying in my school. And we have over 160 professors. And one particularity of our school is our undergraduate students do internships in industry, because we operate 12 months a year, so we have 3 semesters. So students will take 2 semesters in class, they will go out in industry for about 1 semester, they will come back for 2 semesters, on, and to complete their undergraduate degree in software engineering. As you can see, we have about 1,400 students in software and IT engineering, and then about 400 at the graduate level. So my presentation, I will talk about, after a short introduction, I will talk about the standard for very small entities, VSEs. So I'll be using the word VSEs to talk when I talk about small entities. What is a VSE? It's an organization. It could be a company. It could be a government agency. It could be a team. It could be a project of having up to 25 people. I will be talking about software engineering standards. I will be talking about software engineering, system engineering standard, because I know that in Latin America, you often use the word sistema. In the context of 29110, a system is composed of hardware and software, like your cellular phone or your computer. This is a system. So I'll be talking a little bit about 29110 in academia, and also the benefits of the standards, the next steps, and also software quality assurance and ISO 29110, the links between them, and a short conclusion. So let's start with the introduction. My first question is, what is software? So the word software varies a lot between different people, different perspective, and so I'll be showing you different perspectives. So for many professors and students, it is some code that has been debugged and which has been requested as an exercise or project. For software developers, sometimes it is partially tested code. For organization that uses software for a short time, normally there is some documentation that goes with the code. And for organization that keeps the software or a system for many years, like an aircraft or a train system or a ship, those systems will live for 20, 30, 40 years. So the mindset is quite different, and naturally, the documentation is much more bigger, because the people that have developed the software, sometimes they're not there anymore, they have left the company or they retired. So the knowledge that they had in their brain when they developed the software has to be documented in documents, either paper documents or electronic documents, such that they can do the fixing of errors, and they could do some maintenance operation to improve the software, to add functionalities or delete functionalities. So documentation is very important for that domain. So on the upper side, it's more computer science, and as you go down on my slide, it's more systems engineering. So my point of view is more system engineering than computer science. So I know that you have answered my little questionnaire about the cost of quality, but okay, those are the 4 components. So if we were perfect, 100% of the cost of a project will go into the execution of a software, 100%. But we know that we're not perfect. So we do evaluation, we do testings, we do reviews, we do audits. And as we do those tests, we find errors. So there is the cost of correction uh, to make the correction to the software. And as I mentioned before, there is a lot of documentation. So for big software, so it means that we also have to correct the documentation. And if we are intelligent, we will see how we can prevent the defects to be made over and over again. Those are the costs of prevention. Okay, so you have here the cost of execution. If we were perfect, 100% of the project cost will go there. But we have to do evaluation, we have to do reviews, we have to do testing, verification, audits, and we put in place prevention measures like training. And an example of training is what we're doing right now. In a company, we put in place processes, methodology, we put in place or we buy tools, we gather data to be able to analyze the results of our process, and we put in place standards, development standards, configuration management standards. And unfortunately, there is the cost of correction, where we have to do things over and over again, okay? Correcting the defects, retesting, re-reviewing, updating the code, and updating the documentation. And those is what I call the cost of rework. And in the questionnaire I sent you, I ask you, what is your estimate of the cost of rework in the budget of a typical project? So I know that most of you, if not all of you, have never worked in industry, but I look at the questionnaire that you filled in, and we may come back to that later on. So the question I sent to you was to estimate the percentage of the budget that is invested in one of those 4 cost categories. And my point is, if you, and naturally the cost of correction is a very important one, and we want to estimate the cost of correction, because once we have an estimate of the cost of correction, then we can put in place a prevention measure to lower the cost of correction, and eventually get only, let's say, 5% of the total cost of the project could be just cost of correction. 5% is achievable. So my point is, if you cannot provide these process measures, my question is are you really, managing a software development process if you don't know those numbers? And the next questions you had to answer were the percentage or the number of defects injected in a project. When I say injected, I do not mean that you do it on purpose. I mean that you do the best that you can do when you do software, and since we are not perfect, we make mistakes. So one question is, what is the percentage of defects injected? The next one is, what is the percentage of defect detected? And eventually is the percentage of defects that is delivered to the customer. Okay? And if you cannot produce the data, those measures, my question is, are you really developing quality software? How do you know that you're developing quality software if you cannot answer those questions? Because I've met many companies that say, oh, we are developing quality software, we have quality software, and I ask them those questions, and most of them cannot answer. And I say, how can you answer that you're developing quality software if you cannot answer those questions? Okay. So this is a translation from an article many years ago, and I'm asking you to estimate or guess what is the number hidden behind the blue box. What is the percentage of rework that is found typically in industry? Okay. So 40 to 50%. So let's take 50% as a rough number. So it means that for a budget of 2,000 hours, 50% of it, roughly 1,000 hours, is invested in correcting defects. Imagine that instead of wasting 50%, you can waste only 5%. So it means that the difference between your company and a competitor would mean that you would have more money to do research and development, or you can sell the product at a less cost and you can deliver the product sooner. Okay? So my point is, if you don't change anything to the situation, nothing will change. Okay? There will be no miracle. Okay? Nothing will change. A recent article, when I say recent, September of, November or December of 2019, the editor of the column Impact asked themselves, okay, we published the column for 10 years. What have we learned from that? And let's go to this one. So they say that in software, we jump from one fad to another, okay, without learning. That's the problem, is we're not learning from the tools, the methods, the process, the methodology that we've been using, and we jump to another one. Okay. So the author says we cannot call ourselves a software engineer or an engineering discipline if we cannot learn systematically from our errors. Okay? And other disciplines like mechanical engineering or civil engineering have learned from their mistakes, and they have been measuring. If you take jet engines as an example, okay, even car engine. Okay? I remember when I was young that every month or so we would have to go to a garage to get the car fixed. Now you could spend, if you forget about changing the oil or changing the tire, but about just if you forget the normal maintenance, with modern cars, you almost never go to a service station or a garage to fix a failure. Okay, I had my last Toyota Corolla. I kept my Corolla for 10 years, and I never went to the garage for some problem. Okay? I went to the garage to change the oil and the filter. That's it. So there have been tremendous improvements over the years, orders and orders of magnitude improvements, not in software engineering, okay? Because it's like we don't like to measure, and that's very bad. That's very bad because you learn from the measure. So let's see what other disciplines have been doing. So maybe you know about Dr. Ignaz Semmelweis, but maybe you don't know about this guy. So the story I'm going to tell you happened before Louis Pasteur discovered the theory of the germs, just to put you in the context. So Dr. Semmelweis was in the hospital of Vienna. And in that hospital, there were two clinics where mother will give birth to children. In one of the clinic, the death rate due to fever was about 10%. And in the other clinic, it was 3%. Now, if you could look at that, you have an hospital in Vienna. And if you go in the hospital, you turn left, you go to the first clinic with 10% death. And if you go on the right side of the same hospital, you go to the other clinic with 3%. But the thing is, the process of giving birth is exactly the same. Okay? It's the same hospital. So Dr. Semmelweis, when he was hired at the Vienna hospital, he was hired at the first clinic where the death rate was very, very big. And he says women were begging not to be admitted to his clinic because they had 1 chance out of 10 that they would die. Okay? And the thing is, both clinics were using the same medical process, and the process of giving birth is exactly the same. Okay, so he first started to measure. As I said before, the measure is the key. So he measured the percentage of death, and as you can see in the clinic where he was just nominated, you can see that the death rate was much, much bigger about 3 times bigger than in the other one. So he said, let's see what are the differences between the two clinics. So the main difference was the people working in the clinic. So in the first clinic, the, uh, the, uh, the people that were giving birth to the mother were medical students and surgeons. And in the second clinic, it's called midwives. So nuns with women that do that, just that, giving birth to children. So you could have intuitively thought that, oh, in a medical clinic where you have doctors, the death rate would be much smaller, but it is the opposite. And so Dr. Zemmelweis says something is wrong. What's the problem? So he did some observation, and in April of that year, he had about 18% death rate. And again, the germs were not discovered at that time, but he made an observation because one of the surgeon that did an autopsy cut himself with a blade, and then he got roughly the same pattern of symptoms as the woman, and he also died a few days later. So Zemmelweis says maybe there is something that we carry in our hands between the autopsy or the surgery and when we give birth to babies. So he said maybe if we wash our hands in a solution, okay, like a soap, okay, maybe we can get rid of those things, invisible things. And guess what? The mortality rate went from 18% to 2%. So normally you would have jumped and say, Eureka, we found the solution, right? Because that you can see that the factor of 9 diminishing of death between April to June, almost instantly, because he put in place his policy in May, and it went from 18% to 2%. So you say, gee, a factor of 9, he certainly got the right answer. And then he said, if those invisible things that we carry in our hands, maybe we carry them when we touch the tools. So he said, let's use the same solution to clean the tools. And this gave the result of almost eliminating the death of women in the clinic. Okay, almost, down to the 2-3%. So the problem is, in those days, the surgeons and the medical people thought that sickness would come from something in the air. And Zemmelweis was not saying that it comes in the air. It was something that were on the fingers of the surgeons and these medical doctors, medical students. So he was let's say, contradicting the current medical knowledge. Okay? And also, surgeons were offended because surgeons were saying, we are gentlemen, we are medical people. You're all insulting us because you're telling us that our hands are not clean. So doctors did not want to wash their hands. Okay? I say again, surgeons did not want to wash their hands because it was incompatible with the current knowledge, and it was incompatible with their social status of being a doctor or being a surgeon. So this is what we call the Zemmelweis reflex. Okay? Human behavior that's like a reflex where we reject new knowledge because it contradicts current norms. Okay? And sorry. So my question is it possible that people involved in software, like eventually yourself, you'll be software developers, you could also be a customer, and eventually you could be also a professor. Is it possible that you also could experience the Zemmelweis reflex? Now, let's move in time because we were in 18 something, 1800 something. Let's move in time to 2004. And this is an article that I took from the Boston Globe, a newspaper from Boston, where it says that in USA, about 90,000 people die every year because of infections in hospital. And we can reduce by 50% the infection by augmenting just moderately the hand washing. Okay. Now, one hospital found a solution to increase the motivation for the medical people to wash their hand. And now you have to put yourself in the mindset that all of them are either doctors, surgeons, or nurses. So they know about germs in 2004, and they know that they have to wash their hands to kill the germs, not to transmit the germs to their patient. Okay, so they all know that, right? So this is the trick that one hospital used to increase the compliance of washing their hands is by giving free movie tickets if they were washing their hands. Now imagine you're talking to people with many years of universities, and it's like babies. Okay, you give them a candy and they will do what you want. Okay, and like sometimes mother and father do with their little kids. If you wash your teeth or if you eat this, you'll get some candy. Okay, so the hospital was using exactly the same thing with their medical staff. Oh, this is bad, eh? This is very bad. Well, my question to you is, do you think there are some analogies between the germs in medical environments and what we call bugs in software? Think about that. Okay. And also, are there analogy between the medical personnel, and the software developers? Think about that. So let's have a look at what I'm suggesting. So the analogy between germs and bugs, and we'll take care of the word bugs in a few minutes, but right now let's call them bugs. Okay. So the germs are invisible to the human eye, but they can be counted using something like a microscope. Okay. And most bugs are not visible to the majority of software developers, but bugs can be counted using, as an example, software reviews. So bugs can be counted and bugs can be detected with software reviews. And there are medical procedures to get rid of germs, like there are software practices to identify defects and get rid of defects. Since about 1970, and I'll go back to that 1970 in a few seconds. So as you can see, even though we are two different domains, very different, medical field and software engineering, we share a few common things. Now, the word bug, for your information, for your education, in many years ago, the first computers were mechanical computers. They were built with relays. And one day, the operator of the computer said, "Oh, the computer is not working well." So she took a lamp and she walked in the computer room. In those days, computer room would be the size of a house, very big, very big. And as she walked through the computer and looked at the relays, she found a bug in one of the relay. And what you see now on the slide is a photocopy of the logbook of the operator of that computer. So she took the bug and she put a scotch tape over the bug in her logbook as a proof to demonstrate that something happened and the problem was a bug. Okay, so this is the origin of the word software bug. And this is how, now in software engineering, we don't call bugs, we call them errors, human errors that are injected by the developers. So I would ask you okay, now that you know that the word bugs does not belong to the software engineering domain, to use the right word, and the right word is an error. And this is how we eliminate bugs, okay? And you will notice that if you look, you see the product name RAID, and you find funny letters at the lower top of the picture. And I took this picture when I was giving a software quality assurance course in Thailand many years ago. And I found those cans of RAID, and I took a picture for my students back in Thailand. Okay, so the process is we make human errors. Okay, we make an error. And this error may produce one or more defect. And those defects may produce one or more failure. Okay? So the thing is, we have to ask ourselves, how can we prevent those errors? And also we have to find out how to detect the defects. Okay? Because once we produce a defect, we want to detect the defect before the defect gets injected in the software and may produce a failure or a problem. So back to the analogy between the medical staff and the software people. So the medical people think that they do not have dirty hands still today, okay? And software people, because of their big ego, they think that they do not make errors. Other people make errors, but not themselves. It's always the other people that make errors, okay? Many medical procedures are not used by many medical staff, like software quality practices are not used or even ignored by many developers. Okay? And we often treat the symptom, okay, the bug, instead of treating the cause. What causes the error? Okay? And this is what we have to do as software engineers, as developers, is we have to identify the cause, the defect that was made. And why was the defect made? Okay, because the root cause, the first cause is the defect. We find a defect, fine. That is the cause of a bug, okay, of an error. But the real point is to ask ourselves, why have we made that defect? Okay, why have we made that error? This is the fundamental thing. Otherwise, at the end of the day, the patient or customers will have to pay the price. The price could be money, the schedule, an accident or a failure for practices about not using proven practices. Okay, I'm saying proven practices, and I'm going to give you an example in a few seconds. Okay. So I was talking to you about 1970. So Michael Fagan is the inventor of the software inspection. So software inspection is a technique, okay, a process to identify defects and eventually to get rid of them, to correct the defects. Okay. So Fagan was a manager at IBM, and he was initially a manager in the hardware domain. So the place where they developed or they produce chips, okay? The chips that goes into your computer or your telephone. And then he was moved from the hardware department to the software department. And when he arrived there in 1971, he found that there were a lot of defects in the software process, and he estimated about between 30 to 80% of defects were made by software. Now, in hardware, they developed ways to identify those defects because it was very expensive to produce chips with defects, because it means that if the chips had a defect, they have to be thrown in the garbage and they had to be redone again. So they were very meticulous in identifying defects before getting into production, while software developers were sloppy. They were not disciplined, and this is why he had observed 30 to 80% of defects, of rework, sorry. So he decided to develop a process with two objectives: to identify defects in the products, in other words, in the software, but software is not, as I said, is not only code, It's also all the documentation, starting with the sometime with the contract, and then with the project plan, and then with the requirements, and then with the architecture, eventually with the code, with the test code and things like that. Okay, and also to identify defects in the process, because if you have defects in the process, you will still be making defects for the next project. So he says, let's work on both sides. Identify defects on the product and identify defects on in the process. So he decided to implement this process into his department. And this was the reaction of his fellow manager. It does look like a similar response to Fagan that Dr. Semmelweis had from his colleagues, surgeons and professors in medical environment of the Hospital of Vienna. Okay, two different domains, roughly same reflex. Okay, so I contacted Michael Fagan a few years ago, and I asked him, "What about today?" And this is what he answered me. So even after 40 years after the creation of inspection, it's not well understood, it's poorly executed, and it doesn't, people that are using it are not using it to the full potential. When I say full potential, is you can detect 95 to 98% of defects using software inspections. Did you hear me say 95 to 98% of defects detection? Yes, this is how it can be done, and I will show it to you in a few minutes. So the question is, do you remember what happened to Dr. Semmelweis and the critics from Dr. Semmelweis? Fagan had the same thing. Let's have a look at what the Software Engineering Institute is saying. So I'll let you read this sentence. So remember the sentence I said before, if you don't change anything, don't expect different results. So if you know that you're making mistakes, okay, and you have a technique to detect the defects, then why are you not using it? So the SEI says half of the time should be spent into detecting defects. So the challenges of people in industry is as follows. So they want the software development to be faster. They want a better quality. They want it cheaper. The manager wants more productivity. They don't want delays. They don't want cost overrun. And they want to be first on the market. Now, my suggestions after being in industry for many, many years is there is only one secret. And the secret is this. You have the first objective has to be to have better quality. And if you develop better quality, you will get faster product, cheaper product, you will be more productive, and you will have less cost overrun, less delay, okay, and maybe first in the market. Remember, if instead of having 50% rework, you have 10% rework, then the 40% difference means faster, cheaper, more productive, and faster to the market, right? So let's go to questions that customers may ask themselves before they do business or they want to give a contract to a VSE. So they asking themselves, will I get what I want? Will it be successful for me? Will I get the quality and the functionalities that I want within the budget and within the schedule? Okay. Does the VSE has everything that it needs to develop the software? I mean, the developers that are trained, the project manager that are competent, the processes, and the tools. As a customer, what are my risks if I do business with the VSC, with a small company? And once I sign the contract, what should I be watching for? Because things will be happening and I want to be monitoring the project, not to have surprises at the end of the project. And eventually, if I want to do some maintenance, if I want to add, modify functionalities, will the VSC be able to do it for me? And I will show you later on during the second half of my presentation that the standard that I will be presenting will help you, and I will give you examples of getting quality within budget and within the schedule. So from the other point of view, what's in the mind of a VSC? So the VSC says, how can I be known to potential customers? How can I promote myself? How do I know what the customer wants? Because some customers are very knowledgeable about software, but other people are just users, and sometimes they don't know what they want until you show them. And then they say, oh, this is what I want, or they say, oh, no, this is not what I want, right? Will I make profit if I do a contract with customer X, Y, or Z? What are my risks of doing a project with this customer? And also, if I have to hire new developers, how long will it take them to become productive? Will it take them days, weeks? Because I cannot afford that they take many weeks because it's a short project. Okay? And I will show you that the 29110 series will help VSCs in delivering the project within time and schedule. And finally, what's in the mind of academia? Okay, so people in academia, the professor are saying, are our students learning the new design methodology, the latest design methodology, the latest programming language? Are we using the most modern tools, the latest tools? And do we know what students have to learn when they will be working in industry? Okay. And sometimes there is a big gap between what is being taught in academia and what industry or government want. Okay, I'm talking from my point of view because I've been in academia for over 20 years and I've been in industry for about 20 years. So I know that there is a wide gap between those two worlds. And I will show you that the 29110 is one of the first software engineering standard where students can apply it, can manage a project, and can develop a good software project either at the undergraduate or at the graduate level. So let's talk about, again, quality with Watson Free. Watson Free, for those who know the CMM or CMMI from the Software Engineering Institute, Watson Free is the father of the capability maturity model. And I've been very lucky to meet Watson Free way back in 1989 when I did my first visit to the SEI. And I would say that that's the best software engineer that I've seen in my career. Now, so Watson Free did, he was very meticulous and he was teaching people in industry. So he took a sample of 800 engineers, experienced engineers, okay? And I'm asking you to identify what is the hidden number under the the blue box. So typically, so the average of his 800 engineers was about 100 defects per 1,000 lines of code. Okay? So in other words, if you divide that, it's about 1 defect for each 10 lines of code. Okay? And he discovered that there was a big variation between the good developers and the less good developers. Now we're talking about experienced software engineers, and even that, as you can see, the range is about a factor of 5. And I will show you later that it's much, much bigger than factor of 5 for students or for junior engineers or junior developers. But even a factor of 5 is already big. Now, the problem with software testing is there are so many branches to test. In this example, okay, there are only 16 switches, 16 paths, 16 switches, sorry, and there are 70 combination of different paths from point A to point B. So it means that you could have 70 different tests to make sure that you test all the different options, right? Now imagine when you have thousands and thousands and thousands of paths. So in this case, with 400 switches, you've got 13 billion, if not more, different paths. So in other words, it is impossible to test all the paths. So we have to find a way to be more intelligent, okay? Because we don't have the time and the energy and the budget to test everything, okay? But unfortunately, as you can read, most organizations rely only on tests to develop quality software. Okay? Even though, as you can see, it's impossible to test everything. So people are not very intelligent, right? So let's see, let's look at it. So at the bottom, you can see the different activities of a software project. So we've got the start of the project. REQ stands for the requirements phase. HLD stands for high-level design. LLD stands for low-level design. Then we have coding. UT stands for unit testing. IT for internal testing, integration testing, sorry. ST for system testing, and ship is shipping to the customer. So most of the defects are made from the beginning at each step of the process, okay? And once we get into the code phase, let's assume let's assume that we don't inject too many defects. Let's assume that. I know that it's not right, but just for the simplicity of the example. And naturally, we start identifying defects when we start testing. And at the end, there is a gap between the number of defects that have been injected and the number of defects that have been detected, okay? And this is where we have sources of problems, sources of failure in software. So my question is, what are the problems about this approach? Let you think about that for a few seconds. Okay, so going with all those one. So what we've learned is early defects are detected late during the test activity. So defects that were injected in the requirements or architecture are detected only when you have code. If you rely only on tests, you cannot detect all the defects. And unfortunately, the correction of defects is not perfect. So you will be injecting another 10 to 50% of problems when you correct defects, because the logic is as follows. If you are not perfect in developing software, how could you be perfect in correcting the defects, right? So it's the same human beings that have the same problems. So this is why nothing is perfect. And since, and then it means that you will have a lot of rework from previous tasks, okay? And this could lead to a very unstable environment when you're reworking on different steps. So imagine that you are presently doing integration testing and you find a defect in the requirements. So it means that you have to modify the requirements, modify the architecture, you have to modify the test cases, you have to write new codes, and you have to run the series of tests. And as you do that, other people that discovers other defects at other places, and you have to do fixes to the architecture, you have to do fixes to the test cases, you have to do fixes to the software, you have to do fixes to the documentation, you can see that it could become chaos. Okay, so if configuration management is not mature, you could end up into chaos. Okay, and people will get frustrated because they will have to work again, they will have to work overnight, they have to work during the weekend, and sometimes they are not paid for that. Okay? And it means that all this effort means wasted time, wasted profit, and a delay for delivery, right? So the thing is, we have to work more intelligently, not more faster. Okay. So this curve you've seen, this curve you're seeing, and this is the difference. You are reviewing the documents that is being produced, let's say in the requirements phase, you are reviewing the requirements and you are identifying the defects. And in this case, this curve is coming from a book about inspection from Mr. Radis. Mr. Radis was a process director at the SCI, and he's the author of a software inspection book, an excellent software inspection book. And this curve assumes that the efficiency of detection of defects is only 50%. In other words, you made 10 defects, but your capacity to detect it is only 50%, so you detect only 5 defects. In other words, 5 defects will be discovered eventually later in the development cycle. But even that, if you look at the end, the gap is much smaller than it was before, because you have detected more defects sooner, okay? And most probably is that you have detected defects a lot effectively and cheaply. So my question to you is, are you using reviews at every step of your development process? Okay. So again, to work intelligently, not faster, intelligently. So my question to you as students that studying software engineering is, what is your defect injection profile? Because your defect injection profile is different from your colleagues. Everyone has a profile different. Everyone makes different types of mistakes. And as you can see, I'll show you, the number of mistakes from one individual to another varies a lot by a factor of 10. Okay, I don't have time to show you the proof of that, but I have data from a company called Rolls-Royce. And that company, as you may know, manufacture jet engines. So they have to know the quality of their software, okay, that they put in jet engines, because a failure of a jet engine could cost hundreds of millions of dollars. So that company has discovered by doing analysis of the data of their developers that from the worst to the best, there is a factor of 10 in the injections of defects. So my question goes back to you, is what is your own defect injection profile? Let me show you an injection profile of a real company. Okay, so what it shows here that, okay, maybe I'll go back just a second. The bottom is exactly the same what I've showed you before, the different phases during a software project. And the different vertical column shows that the percentage of defect injected during each phase. So if you look at the requirements column, you see that the percentage is 49.1. So it means that in that company, which is, by the way, an aerospace company, in that company, they know, because they have measured it, that not 49% of the defects is made in the requirements phase. Okay, and if you go down to the preliminary design and detailed design, okay, 9% of the defects are made in the preliminary design, and 12% of the defects are made in the detailed design. So if you add 49 plus 9 plus 12, it means that 70% of the defects are injected before one line of code is written. Okay? And what are the dumb people doing? Dumb people are just waiting for the tests to identify the defects. And as you can see here, okay, 70% of the defects are done before a line of code is written. So again, the majority of organizations are detecting defects only by testing. So now you are better positioned to understand why we have 40 to 50% of rework. Waste, when I say rework, I also mean waste. We are wasting 40 to 50% of a budget, of a schedule, of developer time in correcting defects. Now, my next question is, what is your profile for defect detection? Because everyone has a different profile, everyone has different capacity to detect defects, and it varies also by a factor of 10. So on the worst case, you could have people that inject 10 times more defect than the other, and the same individual can have the capacity to detect 10 times less defect than other people. Okay, so those are your worst developers. On the other side of the spectrum, you would have developers that inject 10 times less defect than the other one and have a capacity to detect 10 times more the defect than the other one. So those are your best developers. Those are the ones that you would like to hire or you would like to be a team of, okay? Part of the team. So the good news is there are ways to detect the defects. I talked about inspection, and those are the real number from the same company. Okay, so you can see here that the defect detect efficiency is 96%, 98%, 94%. In other words, they have put in place in their process techniques that allow them to detect 96% of the defects in the requirements phase. Only 4% of the defect will be discovered later on in the process. Same thing in the architecture phase, they detect 96.8% of the defects right there. Okay? And most probably during the preliminary design review, they will identify the 1 or 2 defects that have been slipped from the requirements phase. Okay, so the good news is that ISO 29110 series can help you to produce better quality software. Okay, so we are moving to the next step, the software engineering standard. Why is it important? Okay, my question to you is, maybe you recognize, maybe not, laws of nature. Okay? Nature, as we have discovered as physicists and as chemists and as engineers, the laws of nature. One of those is the Ohm's law, where the voltage equals to the resistance times the current. And if you obey the law, the Ohm's law, you normally you will not get fire, and you will not put fire in electrical instruments. Okay, so my question to you is, and those laws of nature by definition are always right. When I mean that, I mean within our world. I mean, we're not working on the sun, and we're not working at the absolute zero. In our normal day-to-day environment, okay, those laws of nature are always true, whether it is a Monday or Friday, whether it is -20 or +20 degrees Celsius, it's the same. Okay? And if you try to violate the law of nature, you will find out the law of nature will always win. So my question is could you name a law of nature that is a foundation to software engineering? Let you think about that for a second. And the answer is no, there are none. And I don't expect that we'll ever have laws of nature that support software engineering. Okay, we have the laws of logic and mathematics. Okay, that's the foundation of software, computer science, and software engineering. Okay, so the good news is, even though we don't have laws of nature, we have been able to document the knowledge of successful and less successful projects into standards, because standards are documented knowledge. Okay? documented knowledge from successful project and failed projects. So what you see, if I go back just to show you the curve, what you see is from roughly 1987 to today. You can see that the number of standard has increased from just a few to over 150. So it means that during the last, since 1990, so the last 30 years, is the software engineers and software engineering domain has learned enough to be able to put this knowledge into standards. So in other words, we will never have laws of nature to support software engineering, but at least you will have software standard to help you make good decision and good software. So my next question is, why should we use standards? Let you think about that for a few seconds. So read that. So those are the benefits of standard, software engineering standards. Okay. Now, standards will never give you a guarantee, a 100% guarantee. It's not like a law of nature. If you apply Ohm's law rigorously, you always get the good results all the time. Unfortunately, in software engineering, like other disciplines, standards cannot give you a guarantee. But if you use it correctly and if you use the proper standard, it will increase the level of confidence that you'll be delivering a good project. That's all we can provide you. Okay? There is no miracle, there is no magic. It's hard work, okay? But you know now that you have standards that can help you do a better work. Okay. So let's have a look at the house of quality. So at the bottom, at the foundation, you'll see from the left to the right, we have standards and models, we have defects categories, we have configuration management, we have traceability, we have reviews, we have policies and process, we have audits, we have measures, we have verification and validation, the management of supplier, and as we move to the right, we have code of ethics, cost of quality, business models, checklists, risk management. So all that is like the foundation for software quality. And this is embedded in normally when we start a project, okay, we select the proper practices for a specific project and we put that in a software quality assurance plan. And this will allow stable process, capable process, continuous improvement, and the delivery of quality software with productive and motivated employees. And this involves naturally some quality assurance function. It could be one person that do it part-time, or in a large company, it could be a team or even a department, okay, that does quality assurance. But it varies according to the size. And to make that successful, we need some support from management to pay for that, because nothing is free. There is no free lunch. If you want quality, you have to pay somewhere for the quality, right? Okay. So let's have a look at the standards, and more specifically, we'll have a look at the 29110 standard. So just to give you a hint, in this figure, there are a bunch of numbers, but what I want to show is there are software engineering standards that covers everything in the software development project. When I say everything, I mean everything from the vocabulary to the process, to the quality of the product, to the testings, and naturally, as I said, to software processes for small organization. Why are small organizations important? Are they important? So those are data, this is data from European company. And as you can see, there are about 98% of European companies that have less than 49 employees. Okay? As you can see on the first line, 92% of company in European countries have less than 10 employees. 92% have less than 10 employees. That's a big number. Okay? And the large companies with more than 250 employees, they count for only 2%, 0.2%, just 0.2%, right? The problem is initially standards have been developed by large enterprises to meet the needs of large enterprises, and they forgot the small enterprises. This is where 29110 comes. Okay? So this is a pyramid of a real company, a Japanese company that produces electronic components, electronic products, I should say. And he is at the top, and he has 60 prime supplier, and the prime suppliers have 600 suppliers, and those suppliers have also at the lower level 6,000 producers. Now, a problem happened in one of the very low-level producer. A defect was made and was not discovered, and naturally, that defect, unfortunately, was integrated in the product and sold to customer, and the cost to repair was $200 million to the manufacturer. Okay, so the circle means that, remember the definition of VSEs, it could be a small enterprise, it could be a project, it could be a team. So there are VSEs at all levels of that production chain, even at the high level of the manufacturer. Okay? Even there, they have small teams and small projects with just a few people. So back in 2005, when I became the editor of the standard, I did some observation. And one of the observations was this: most software engineering standards have not been designed for VSEs. And VSEs have a negative perception about standard. They think the C standard as being expensive, that are producing a lot of documentation, and they are like bureaucracy, okay? And many VSEs, their process is ad hoc or chaotic, and most of them are not documented. They are within the heads of the developers. But on the other side, if you remember the pyramid that I showed, the products produced by VSEs or the components is very important to the world economy. So I said, we have to find ways such that VSEs around the world are using on a daily basis standards adapted to their needs, which guide them to develop quality software to improve their productivity and their competitiveness. So to do that, I decided to participate actively to the development of software standards for VSEs to accelerate the adoption and the implementation of the standards, like what I'm doing a little bit today with you, and also to work to develop educational material to teach standards to undergraduate and graduate students, roughly what I'm doing also with you today. So at the very high level, we have the ISO people that produces thousands and thousands of standards, and there is a subcommittee 7, which is mandated to develop systems and software engineering standard. And my working group 24, has been mandated to develop standards for VSEs since 2005. And the flags that you see, or the logo that you see, are the flags of the country that participate to the development of 29110 since 2005. So we did a survey to identify the needs of the VSEs back in 2005 to identify the problems and solutions. Okay? We did a survey translated in 9 languages to make sure that we could reach the people all over the world. And we found out that just a small portion were certified, But 74% of the respondents said that it was very important to be recognized or certified, either nationally or internationally. Okay? And 62% said that they wanted to have guides and examples, lightweight standards with templates. Okay, so let's move to the solution. So this is the spectrum of approaches. So on the horizontal line on the right side, you have the high ceremony with a lot of documentation, traceability, configuration management. On the other side, on the left side, low ceremony with almost little or no documentation, light or no process. And if you look on the vertical axis on the top, we have the waterfall approach with almost no risk. Everything is known. This in reality almost never happened. Very rarely everyone knows the requirements and there are no risks. Most of the projects have risk. I should say, sorry, all projects have risk by definition. All software projects have some minimal risk. And on the bottom, you have the iterative risk-driven approach. So 29110 is right in the middle, sorry, where we have some documentation, we do some configuration management, but we can also adapt for different life cycles, and we can also be agile. Okay, so we have developed a series of what we call profiles. It's like Russian dolls, where a small profile is a subset of a bigger one. And I will show you what it is in a few seconds. Okay. So the profiles that we developed is guides for the startups or very small projects, 6-person months project. So that's called the initial or the entry profile. Okay. Next is the basic profile. We have one team working on one project. Okay. Then the VSC could have more than one team working on more than one project in parallel. This is the intermediate profile. And for the advanced profile is we want to make sure that the VSC will continue to grow and be competitive, because we know that startups, they die very, very soon. 80% of startups die within the first 5 years for many, many different reasons. So since we know that, we said, let's provide the VSC with 4 steps, such that we will help them to grow and will help them to produce quality software, which should provide them some money, some profit to stay in business and eventually to grow. And we made the entry profile and the basic profile guide freely available on internet. So we have developed a set of documents. So the overview documents is for everyone, and we have developed standards. So standard tell you what to do. Okay, this is the content of a standard. A standard tells you what to do. In other words, standard is a list of requirements. Okay, and the bottom one are the guides. So guides are specifically for VSCs, and they tell you how to do things. Okay, not what to do, but how to do things, like a recipe. Okay, like a cookbook recipe. And you obtain a few of those guides freely on internet. And there are also Spanish version of part 1 and Spanish version even translated also of part 1 and the basic profile guide in Spanish. Some from Uruguay and some from Peru, and some from Mexico. I'll show you from Mexico in a few minutes. I'm working with people from Mexico, from CMAT in Mexico, and they have been translating with people from different universities of Mexico the entry profile guide, which has been published just a few weeks ago as a official standard from Mexico. And ISO has even published an official version in Spanish. It's one of the first time, if not the first time, that the software engineering standard is published by ISO directly, and it is also freely available on internet. in Spanish. Now let's have a look at the inside of the basic profile guide. So we have a customer that knocks at the door of a VSE, okay, with a description of what it wants, a statement of needs, a list of functionalities, and eventually the VSE will say, yes, I want to do the project, or no, I don't want to do the project. So if the VSE says yes, then the project management process will kick in, and the project manager will do a project plan. Then the project manager will start executing the project, and you'll do the standard software engineering activity that you've been learning to do, I guess, in your curriculum at the university. Okay, so on the right side, there is nothing new. Okay, and as you execute the plan, you evaluate if you are against the plan, if you are according to the schedule, according to the budget, and if you have things that you have to modify in the requirements. Okay, and eventually you finish the product and you close the project and you deliver what the customer has requested. We call this software configuration, meaning all the documentation that the customer wants, and also the software. Okay. Now, even though the right side looks waterfall, see those blocks as Lego blocks that you can assemble, okay, for different life cycles, okay, like a bunch of Lego blocks. Okay. Same thing for the project management. Those are just Lego blocks. Now let's have a look at the different components of a process. So here we have the project management process, and we have, as I showed, 4 activities. I'm showing here 1 activity. We have entry products, in this case, the statement of work or the list of needs. We have internal products like meeting minutes that the customer doesn't want to see. And naturally, we have output product, which is what the customer is paying for. Okay? Now, let's have a look at 1 task. So now what you see is the high-level process. Now let's have a look at 1 task. So here we have 1 task of the requirements analysis activity. On the left side, you see that there are 2 roles involved in this task. There is the customer and the analyst. And you see here, this is the title or the short description of the task. It says validate and obtain approval of the requirement specification. The bottom text will give you more amplification, more detail about this task. We have the entry product, in this case, the requirement specification that have been verified internally by the team. And after this task has been executed successfully, then we have the results of validation, and we have also the requirement specification with a different status. It moved from verified to validated. So you can, in the 2 processes that I showed, every activity is composed of tasks, and every task are described like that. Okay, and also for every work product there is a description. In this case, we have the result of validation, and it's briefly, this is what it is, and it says, okay, a typical validation could have this information, and the source of this document is the software implementation process. Now, to help VSEs in implementing the basic profile, we have developed a set of deployment packages. In other words, we have broken down the basic profile into different components. Okay, and what is in the deployment package are steps. We have templates, example, checklist, and mapping. The good news, and this is the list of the deployment package. Okay, so you have construction and testing, verification, validation, project management, etc., etc. So those deployment packages have been translated in Peru, and they're also available free on the internet. Now let's have a look. Let's have a look at a few projects, okay, rapidly at a few projects, because time is passing by. Okay. So one project is a startup in Peru, okay? Agile, basic profile with Agile, a project of 800 hours, and a percentage of rework of 18%. A developer of cosmetics, a small project using the entry profile with 12% of rework. An IT startup with the basic profile, a project of 990 hours, and a percentage of rework of 12.6%. And just to give you an example that even there are VSCs in very large organization. So this is a very huge organization in Quebec, in Montreal City, very close from me, where the IT division has almost 2,000 people working on 2,000 applications. But there are many, many small teams. And one of those small teams was one of my graduate students working as a team leader, a team of 11 people. And they developed a software for that company with a 1,500-hour project using basic profile and Scrum. And the percentage of rework was 9.6%. Now, if we look at this curve, this is a curve from a real company called Raytheon. And it shows, according to the maturity level from 1 at the bottom from 1 to 4, it shows that at the level 1, they had 41% of rework. And that as they improved the processes, they went from 41% to 18% to 11% to 6% to 5%. Okay, so this is the cost of rework. So you can see that the startup in Peru had 18% rework. The startup in Tunisia has 12% rework. The public utility at 9.6 and the cosmetic at 12%. So my point here is the implementation of proven practices accelerated the maturity of organization. In other words, instead of reinventing the wheel and wasting a lot of effort in rework, if you use proven practices, then you should have less rework. And for those 4 organizations, they were using the basic profile for the first time in the first project. And even for a first project, they have a percentage of rework showing that similar to higher maturity level. Cool. So let's have a quick look at the company in Peru. So this is the typical data that I've asked them to gather as they were developing the software with my colleagues in Peru, in Lima. So prevention, execution, evaluation, and correction. So during the project, they tabulated those timing and they computed the percentage of rework, okay, 18%. They were the first company in Peru to be certified officially. So they had their certificate, like you can see on the right side of my slide. Okay. If you want to read more, okay, you can go on my website. I will show you the page later on. You can read, download this article and read it. Okay. A look at a large financial institution, a bank. Okay. Again, with 3,000 employees, a large institution. But the team leader that I was working with, one of my graduate students, the team was composed of 6 people. Okay. And before they applied the basic profile, they had typical complaints from customers. Okay. Customers were complaining about the list of things that you can see. So this was before they implemented the basic profile. Okay. And this is the snapshot of the process before they implemented the basic profile. As you can see, there are many things that were missing from the project management process. Okay. And this is often the cause of a poor project. The cause is not that people are not good technically. It's most of the time people are not good at managing projects. And here you can see that many things of the project management process were not done correctly. But on the other side, they had about 2/3 of the tasks done correctly about software engineering. Again, this was before they implemented the basic profile. So the result was about in the middle of that curve. They implemented the basic profile, and you can see that the number of incidents, because this is how the bank works. Okay, users or customers will write an incident report, and they will qualify the incident, the impact from 1 to 5. And as you can see, as you go to the right side, there were less incident and less major incidents, okay? Because they were now using the basic profile. Quick look at the big company. One of my students was working in a big company where they were doing systems engineering. So a large company, okay? But they had a good process for the big project, but they didn't have a very good process for the small or medium process. So they divided their projects in 3 categories according to the duration, the size, the number of engineering specialties, the fees, and the percentage of projects that were in that category. And as you can see, 95% of the project were small or medium projects, and they didn't have any process for that. So what they decided to do is to use the entry profile to manage the small projects and the basic profile to manage the intermediate project. And what are the benefits? So they did the calculation of the benefits of implementing the standard. And over 3 years, they have estimated that the cost to train the project manager, to develop the website, to update the checklist, to update the process, versus the benefits, as you can see. So the return on investment is significant. In other words, there was a value in implementing the standard because there was very large economical benefits. So you can read this article on my website. Few minutes about system engineering. When we talk about system engineering, most of the time, software is just one component of a system, okay? One component. So we have exactly the same 4 profiles, but at the system level, systems where, as I mentioned before, we have hardware. So no surprise, it looks like the basic profile that I showed you before. The only difference is on the right. You're not at the software level, but you are at the system level, okay? And when it's time to construct the system, to buy the components and to develop the software, then if you develop the software, if people are intelligent, they will use the 29110 for software, okay? And then they will integrate the software to the hardware. And we have also developed a series of deployment packages. Unfortunately, they have not been translated in Spanish yet, but they are available in English. Quick look at a company that developed, that used the system engineering process in Montreal. Company, a startup of 4 people, okay? And they used a basic profile to develop their process, because a startup cannot start at CMMI level 2. A startup will die if it waits to have all the process developed for CMMI level 2 before it makes money. So they decided to use the basic profile from system engineering as a base, and as they were getting money and contracts, to add missing practices to eventually become level 2. And so they have developed 3 types of processes for different types or size of projects, for the small projects, medium project, and the big projects. Okay, and it works. A project I'm working with in France, just to show you from another perspective, project that has been completed just last year. So you see on the left side, different domains from space, from agriculture, nuclear, automotive, different sizes from 10 employees to 150 employees. Okay, so we have here a lot of VSEs, okay, and in nuclear environment, 150, it means that they have small teams of 5, 10, 20 people, and also different year that were established. So young company established a few years ago in 2016, and older company established in 1994. Okay, so if you want to read more, unfortunately, it has not been translated in English, in Spanish, sorry, but you can read it in, if you go on my website or on ResearchGate. And We have produced a book in French called Les Clés de l'ingénierie système, published in 2017. And we are almost finishing an English version of this book, which should be published in a few months. And eventually, maybe if there is an interest in Spanish. Few words about academia. Okay, so there are over 20 countries that are teaching 29110, and I guess that most of you look on the left side to see if Ecuador was part of that list. As you can see, yes. Okay. This is not for you to read because it's small, but just for you to illustrate that in Mexico, certain number of universities have been certified to 29110 as if they are a company. In other words, the students are doing their projects at the end of their program. We call them the capstone project, the team project. And in 2017, 4 universities of Zacatecas state had been certified to 29110. Okay. So the benefits, roughly the same benefit as a company, okay, but applied to the student context. So the beauty of this is when students learn 29110 in university, when they get into the industry, they bring with them this knowledge, they bring with them the process, they bring with them the guide, they bring with them the checklist, such that they can be much more efficient in the company. And we're also working on a game with my colleagues in Mexico to teach and learn 29110 based on the monopoly. Okay. And also we had for the last 3 years, unfortunately not this year because of the pandemic, but we had for the last 3 years robot competition using robot that I will show you in a few seconds, using the basic profile. And this is a 3-day competition. So in 3 days, you cannot do everything, but you can do many things. Okay, so those are the 2 robots that we've been using. Say one robot that we use for 2 competition and another robot that we use for 1 competition. Okay, small robots, easy to assemble and easy to program. So students, part of the competition, had to do a mini plan, just 2 pages. Okay. 3 pages of specification, 2-3 pages of design, some test cases, some documentation, a minimum traceability matrix, and a few slides to present the results to the jury. So teams of 5 to 6 people, coached by a professor, and it was a real success. This is why we did it 3 times. Now, if you want to learn more, you can go on my website, which is in English, French, and I have some pages in Spanish. Okay, everything on my website you can download. And this is some marketing for myself. We have written with my colleague 2 French books on the left about quality assurance, and recently in 2018 we published a book in English with Wiley and IEEE, a 600-page quality assurance book, and we are presently working on a project to translate it in Spanish. Okay. As soon as we get a few technical problems solved, we will start the translation. Now, what are the benefits? So this is an example from Thailand. Thailand has established a national strategy to implement 29110. When I say national, it implies industry, it implies the government, it implies the academia, and actually it implies VSCs, and it implies students, professors, and auditors. And so this is the list. They have 10 universities teaching 29110, and I was teaching 29110 in 2009, so 11 years ago. About that time, I was in University of Chiang Mai teaching 29110 to undergraduate students. And they have certified so far close to 500 companies and public or government organizations. So this is Thailand. Now it's going back to Mexico. I've been working in Mexico since 2016 or 17, and I was in 2017 in Zacatecas, where we developed an action plan with the Secretary of Economy to help the VSC to be more competitive. And I had the pleasure to meet the Secretary of Economy of the state of Zacatecas. The Secretary of Economy is an engineer, and he was he could easily understand the motivation and the benefits of implementing software engineering standards in VSCs of Zacatecas. So just as a quick look, small enterprises, as you can see, small VSCs, right? 12 employees, 3 employees, 4 employees that had obtained certification. So they were the first one back in 2017 to get certified. And so this is the 2017 view: 4 companies, 4 universities, and in year 2019, 7 new VSCs were certified, 2 companies and 5 universities. And right now, 3 companies and 2 universities are being certified. If you want to read more, you can look in this article about Metropolis software that I wrote with my colleagues of Zacatecas, Mirna, and Israel. Now, benefits, let's look from the point of view of VSCs, because it's very good to have produced standards. We can say we have done a beautiful job, but we did a survey a few months ago, in 2018 right now, and we asked them, we asked the VSCs, we had the customers and the auditors and the professor, are you happy with the standards that we have developed? And I would like to thank Dr. Mirna that had graciously had accepted to translate in Spanish the survey. So we asked them, did you see any improvement in productivity? Okay, and how long did it take? Okay, and as you can see down the slide, in the first few months they saw improvement in productivity. Okay, and then we asked them, did you see also improvement in quality? Again, within the first few months, they saw improvement in productivity. And then we asked them, are you satisfied with 29110? And vast majority, 89%, said they were completely or largely satisfied with 29110. Okay, so that's a sign that the standard that we have developed was good for the VSC. Okay, now we ask the customers that used a VSC that were certified or not certified to 29110. And as you can see, again, a vast majority of the customers were very happy with the product delivered by their suppliers. Okay. Now we ask professors why they were using 29110, and they said that they were using 29110 to teach basic software engineering practices, basic project management practices, to teach them how to use standards, okay, to introduce them to standards, to talk to them about quality assurance, because when we talk about a software engineering standard, it is talking about software engineering standard, and also because local company and local government were interested by that. So here we have, we know that a few professors for university have been teaching for up to 9 years, software engineering standard with 29110. Motivation to teach, it's easy to understand. Okay, students were motivated to learn, and there are some teaching material, like a colleague of mine in Latin America. She's, as an example, teaching with the quality assurance book. So I sent her via email all the PowerPoint slides to help her start a quality assurance course in her university. So if you want to read more, you can look in the recent article that has been published just a few weeks ago in IEEE Computer about what we did. Now, benefits. So we see here the day-to-day benefits of 29110. I'll let you read this. So those are day-to-day benefits, but there are also, from the point of view of the business or the organization, business benefits. Because the questions from any VSC, any company is, what are the benefits for me if I want to apply your standard? And this is a list of benefits that we've seen. So we have not reinvented the wheel, okay? I'm not saying that we invented the wheel. We have just selected the proper practices. We have just selected the minimal number of practices such that a VSC can do a good software product within schedule and within the budget. That's it. This is what we did, okay? Now, what's next? So the next slide shows the portfolio of 29110, but I want to emphasize the two blue box. In about 2 weeks of the time, we are going to have a meeting with my working group. I said 2 weeks, sorry, it's in about a month. And we are going to review the Agile Guide. Okay, the Agile Guide has been developed by my colleagues from Mexico, from Mexican organization, and mostly from Mexican universities of Zacatecas and Aguascalientes, and also from Guadalajara. So they have produced the Agile Guide. The Agile Guide is being presently reviewed internationally by different countries. We should get the comments, and we'll be improving the guides and publishing the guides in 2021. And also at the next meeting, we should get the first draft of a DevOps guide, which will be again reviewed and eventually published by ISO in about 1 year. And the other thing is we are started to work in the space domain, and I will show that in a few seconds. So we are developing guides for VSCs that are developing non-critical software for space organizations. Okay. The reason is simple, is the money in the space domain, they are not, it's very expensive, as you know, to work in the space domain. So the space domain organization said if they could have a certain number of certified VSCs that are certified to the space domain software, then they would see the benefits that I showed you, okay? The benefits are tangible. So the benefits applies also to space organizations. So the basic profile guide is first to reinforce those who are already using an agile approach based on Scrum and XP, okay? And for those that are already using the basic profile in, let's say, a more waterfall or non-agile approach. So the guides that we will be publishing will help those two types of VSCs in implementing agile practices in the control environment. So they could be certified also. That's another important point, is the VSC that will be applying the guide could also apply to become certified. And those are the space agencies that are working to develop the space guides and the space specification, space standards for VSCs. As you can see here, you have big names of large organizations. So they're working together to become more efficient, okay, more efficient. Okay? And it's based on the basic profile right now. And naturally, it's some elements of to complement, because the basic profile is generic. So for the space domain, they are using components of the European space standards as addition to the basic profile. Assurance quality assurance. So what is needed to produce quality within budget and schedule? It's a bunch of things, a bunch of activities that are synchronized like a clock. Okay, many things have to be done in parallel or sequentially to be able to get a good product within quality within the budget. No surprise, no miracle. It's engineering, it's hard work. Okay, but it can be done. Okay, so the quality house that I've showed you contains all the elements to do quality products, quality software. And the quality house has the components related to 29110 in many chapters of the book. Okay, almost the last slides. So my recommendation to academia and professors and students is to teach 29110 in many courses, to use components of 29110 in the requirements course, in the architecture course, in the project management course, okay? In projects, in short course, short team project or capstone project. For the government is to implement 29110 in their own project, like they do, as an example, in Thailand. Okay? In Thailand, there are many government agencies that have been certified to 29110. To educate their suppliers about 29110 and to motivate their suppliers. As an example, in Thailand, again, they have tax reduction, they have economical benefits if they are certified. And also, a government also has to motivate academia to teach 29110. So for companies, we're asking them, implement 29110 in your own projects. And for customer, we ask them to motivate their own supplier to implement 29110. You saw the data from our survey. We have happy VSCs and we have happy customers. So customers should say to their VSCs, if you want to have a contract with me, go and get certified. And for suppliers of software, they have to implement in their own project. Also, sometimes they have to educate their own customers, to tell to their own customer, this is how we work here. This is the process we are going to follow. And this is, Mr. or Mrs. Customer, the steps or the activities where you will be involved in the project. You will be involved, as an example, in approving the project plan. You will be involved in validating the requirements to make sure that we are developing the right requirements. And you will be involved in approving the final software, okay? And this is how we will be working with you. And this is the process we'll be using. So there is no miracle, there is no magic, there is no mystery. Everything is visible, okay? So going back to this, this slide that I showed before. So if you can provide these process measures, maybe you are really managing a software project. And if you are providing those quality measure, maybe you are also producing quality software. Okay. So in conclusion, so 29110 was developed specifically for VSCs. VSCs that are developing software or systems that have software and hardware components. And so 29110 is intended for VSC that do not have the expertise, not the budget, not the time to adapt existing standards to satisfy their needs. We have developed a 4-stage roadmap to help VSC to become competitive, to be competitive from startups to grown-ups. We have at least 20 countries that are teaching 29110 at the undergraduate and graduate level. And I have demonstrated, I hope, that 29110 is successfully used by government agency, by startups, by grown-ups, large enterprises in many countries. And 29110 bring benefits, not only economical benefits, but it brings other benefits to their customers, to their partners, and also to their employees. So back in 1968, this is what they said. We build systems like the Wright brothers built the first airplane. We build the whole thing, we push it off the cliff, we let it crash, and we start over again. Right? And in 2020, I'll let you read this. Unfortunately, yeah, many companies are still not using proven practices from published standards. Remember Semmelweis? Remember Fagan? Okay, Fagan was in 1970. Okay, so it does look that new software engineers or company do not learn very quickly. So my questions to you, and maybe to your professor to discuss after my presentation, is why do a large number of software organizations ignore or don't use software practices that have been available since the 1970s? Is it because software developers and software managers have a too big ego? Okay, because they say, oh, well, I don't need a standard because I know how to do software and I don't make any mistakes. Is that the reason? My next question is why so many software people not working smarter and not using proven practices? Okay. Maybe software engineers must address their sociopathic traits that are defined mostly as being antisocial behavior, not too much empathy, and some big ego. Okay. So I thank you very much for your time, and we have time for questions.
Thank you very much, Claude. Very, very interesting presentation. And yes, we have time for questions, so this is the moment when you guys can ask or do comments. As you know, Claude, we used your book actually in this class. The first chapters we read and also solve some exercises. So if the students want to talk about that also, they are welcome.
Okay.
Henry is raising his hand. So go ahead, Henry.
Hi. Well, I just want to thank you for your time. And I have a question about, you talk about a profile in injection and detecting the errors.
Mm-hmm.
And so my question is related to how can we check our profile? I mean, I don't know if there is a test or an exam or an exercise. I don't know what's my profile. So I just want to ask you about that.
Yeah,
thank you.
Excellent question. Excellent question. So this is where you begin to become smarter by asking yourself, what about me? So my suggestion is you should be doing reviews, okay? Preferably software reviews with checklist. And as an example, maybe if you have some time later on, Sandra, I can give you a short presentation about a course that I present, a workshop about software reviews. But if you do reviews on yourself, okay, you will eventually identify the defects and eventually you will build a little spreadsheet, very simple spreadsheet, okay, where you will be able to find out that where you are injecting your own defects, and you will be looking at the type of defects that you're making. And if you are smart, you'll say, okay, now that I see the type of defects that I make, what can I do to prevent this? Could I add a checklist that's on my requirements checklist to make sure that I don't make this type of defects anymore? Could there be a tool that can help me? Or is there some knowledge that I miss or that I do not understand that make me make those type of mistakes? And as you find the right answer to your question, then as you do new project, if you're right on the right place, then you will be making less mistakes. And probably you will not be making the mistakes that you were making before because you have put in place on your own process either checklist or elements or tools or knowledge that now prevents you from making those mistakes. But don't worry, nobody is perfect. Okay, nobody is perfect. There is only one person on the earth that claims to be perfect, and it's not me. Okay, so we have to have a low ego. We have to learn from our mistakes, one day at a time. Okay, one day at a time. Did I answer?
Thank you so much. Yes, thank you.
Okay. There is something in my book about that. Okay. But again, as I said, if you are interested, maybe we can talk with Sandra, and I can give you maybe a short 1 hour presentation on how you make that little chart, that little spreadsheet, and what you can learn, because you can learn a lot of things from a little bit of data. But to do that, there is one prerequisite. Uh, your process has to be stable. If you have an unstable process, a process that varies a lot, then the data will not be very useful or meaningful. So if you use it on yourself and you have your own process and you follow your own process from one project to another, then you can assume that the data that you'll get out of your process for this project for you is good. For you is good for you to learn about yourself. And as you do more project, you get more knowledgeable about yourself, and you'll get also more knowledgeable about other people. And eventually, if you decide to become a team leader or a manager, then you can say, okay, this approach have brought many benefits to me. Maybe in the process that my team will be using, I will be collecting this data also. Okay? I will be collecting the process data, and I will be asking my developers to collect their own data, which could be kept confidential for them. But I want, as a team, as a manager, I want to collect the data about the process to be able for me as a manager, to improve the process, okay? To produce a better product. Remember Fagan, his inspection process objectives was to detect defects in the product and detect defects in the process. So this is how you can improve yourself, and eventually as you get into industry and as you get promoted or go to a management job, then you can bring this data with you. And if you've done it for a few years, then you can show to your colleagues, you can show to your team members, hey, this is what I've been doing. This is not a secret. This is not rocket science, and it works, okay? And it costs nothing. It costs a little bit of time, but you don't need sophisticated tool. You need a little spreadsheet, and that's it. Other question?
Thank you.
Thank you. Yes, I think we have time for another question.
Okay.
If anyone want to ask something, this is the time. I guess they are shy.
No problem. No problem. They can ask you the question later on. We are meeting tomorrow morning again. And
Yes.
if you have questions from them, then you can bring the questions to me tomorrow morning, or send them via email as an example, if you want.
I'll do that. I'll do that. And I'll definitely be in touch with you to work in future. So thank you very much. Before we go, I have just one announcement. Esta semana no tenemos tareas, solamente una lectura. Entonces, revisen el aula virtual, hay que leer el capítulo 4 y simplemente conforme tú lees, ir anotando las preguntas que tú tengas sobre ese capítulo y los ejercicios, las resoluciones que están ahí mismo, ¿no? La próxima semana nos vemos para hablar de ese capítulo y también para definir cómo va a ser el examen. Entonces, eso sería todo por hoy. Muchas gracias. Thank you very much, Claude, for being here, and I'll see you tomorrow.
Welcome.
And thank you, everybody. Have a nice afternoon.
Bye-bye. Hasta mañana for you.
Hasta mañana.
Thank you.
Bye.
Thank you very much, guys.
Gracias.
Nada, que estén bien. Por favor, lean el capítulo 4 y suban sus preguntas al aula.